Hi, in this video I'm trying to prove something which is very important for the Dataguard setup. That is how redo content shipping and archive log shipping happening in the Dataguard setup is what I'm trying to prove in this video. And the most important concept that for us to understand here with this video is what are the background processes involved in shipping the redo content from primary to standby. Similarly, in shipping an archive log file from primary to standby, whenever there is a lag or archive log gap between the primary and standby. And additionally, along with this, I'll also try to prove if the archive logs are being pushed from the primary or not is what I'm going to prove from this video. So to prove that, I have enabled my network monitoring from my primary database server. If you can see on the screen on my putty session, there is a network monitoring already started on my primary server. If you to let you know what is this naming conventions, OEL is the primary database server host name, and OEL standby is my standby database server name. So as you can see the arrow marks like this, it means the packets which are being transferred from primary to standby is what this arrow mark says. So if you see the amount of data which is being transferred for every second, because this will keep refreshing for every 2 seconds, and you see that the contents are basically being transferred from your primary to standby, and vice versa. If you want to see the contents which are shipping from your standby to primary back, that's why you can see an arrow mark like this as a reverse order. You will see that the content or the amount of data being transmitted from standby to primary is what you can see in the second row. Basically, it will not be in more than bytes or 1 kilobyte at the maximum. So that's why you can see that it will be always less than 1 kilobyte from standby to primary, because mostly redo contents are the contents which are transferred from your primary to standby. That's why the traffic will always be flowing from your primary to standby. That's why you can see here the traffic content is always in kilobytes. So this is my primary database server on which the archive log sequence number currently is 146, and this is my standby database on which the current archive log sequence generated and applied is 146. So let me simply just test if my both databases are in sync or not. There are many other methods to check, but I'll just do a switch log file and verify if they are in sync. If 147 is applied here, then that means it is in sync. So I'll do a very simple test like this to verify if both the databases are in sync or not, and they are in sync at the moment. So first of all, when the databases are in sync, that means the redo contents are being shipped from your primary database server to the standby database server. To identify what is the background process which is doing this, let me do the test now. But before that, people will, I heard many DBAs saying that the redo contents from primary is actually being shipped to the standby by your log writer background process or your LNS background process or any other background processes. But I will be answering you shortly, or you will get to know the answer. What is the background process actually shipping the redo contents from primary to standby whenever primary and standby are in sync, first of all. So let me show you. Before that, on my network redo transport or whatever packets being transferred from primary to standby, let me identify the port number on which my primary, this is the standby, and what is the primary port number? So this is the port number which is used over the TCP IP protocol to transfer the contents from your primary database server to the standby database server. Now what is that we do is, let us identify who is using this particular port number. So I'll simply use ls of -i this one 9338. Now you can understand a background process with the PID called 2491, which is running with Oracle user, is using this port number of TCP IP protocol 9338. Now let us identify what is the background process doing this job. So the PID of it is 2491. Now this answers your question. So which is the background process of your database which is shipping the redo content from your primary database server to standby database server? It is NSA. So you can also find the details of this background process in the Oracle documents, saying the job or the responsibility of the background process NSA is to ship the redo content from primary to standby database server whenever you configure an asynchronous mode of Dataguard setup. So I have literally proved it from the network monitoring, which is the background process is responsible to ship the contents from primary to standby. Or this will also help you guys to understand now what is the background process doing this job. It is not logwriter, it is not LNS, it is NSA. Now let us also try to prove if there is a redo log gap from primary to standby, which is the background process which will be shipping the contents from your primary to standby. That is the next thing that I'm going to prove. Now let me actually generate an archive log gap. So to generate an archive log gap, I'll be actually deferring the second archive log destination. So the status of the second archive log destination, I'll make it as defer from enable. So the current status of this second node is enabled. Let me make it defer. Alter system set is equals to defer. So once I defer the second node or second state, second archive log destination state, now let me do some archive log switches. And I'll just keep doing this so that I have to get too many archive log gaps from node 1 to node 2, sorry, from primary to standby. Now if you check the current archive log sequence number of the primary, it is 184. Now just check the last archive log sequence number which is received on the standby. It is only 148. That means approximately 36 archive log gaps are there from primary to standby. So all these archive log gap resolution must be done automatically by your Dataguard setup as soon as I make the second archive log destination status to enable. But what is that we are trying to prove? Which background process which will be responsible to resolve this gap from primary to standby is what we are going to prove. But along with that, let me show you something again interesting part. As soon as we have made the second destination as deferred, you can observe that there is no network traffic at all between your primary database to standby database at all. There is nowhere you can see an other database server with the name OEL-standby. That is not there in your network traffic. So you can understand one more thing, that if you just make the second archive log destination as defer, though your recovery process is running on your standby, it doesn't make any difference to your Dataguard, it is paused. So you can just say that if you make the second archive log destination as deferred, your complete Dataguard setup is paused. That is what the next proof you get automatically from this network monitoring, and you can see that on the screen. Now let me enable this second archive log destination, but before that I will have another session open to actually identify which is the background process responsible for my archive log shipping from my primary database side to standby database side. For that, let me generate another session. Let me open another session on my primary database side. So I have my third session of my primary database side ready with ls off command, just to give the port number, whatever port number was using on the network, because here there is one concept. As soon as the archive logs are shipped completely from your primary to standby, again the port number will be occupied by your NSA background process. So that's the reason I have kept this third session ready, so that we will have to quickly see, after we enable this redo log archive log second destination, after we enable it, we have to quickly see what is the background process shipping or doing some activity of shipping the contents from primary to standby. So that's the reason I have kept this ready. Now let me make or set the parameter value to enable on my primary database side, the second archive log destination I mean. Now I am running this command, but as soon as I run this command, just keep an eye on top of this particular network traffic flow which is there here as soon as I start this. But along with that, I should also identify which is the background process doing the content shipping from your primary and standby very quickly. So I am just pressing return here and very ready here. So 9624, just see 9624 and 9625 as well. Sorry, so it is gone. So I have given the wrong 34 instead of 24. That's the reason I was not able to get the background process. It is still showing NSA because it has completed shipping all the 34 archive logs in a very fraction of second. So I have to be little quick again to actually capture the process, port number, and to check what is the background process using that port number again. So let me do that for you. Now if you see on the standby, all the archive logs are shipped. So it was very quick. In a fraction of a second, all the archive logs are shipped, but I could not identify because of the wrong number that I have given which background process has done this. But I'll be proving it now again. So to prove that again, I'm again generating an archive log gap between primary and standby by deferring the second destination, and I'll again enable it and redo this. Now I have generated too much gap, and now it is 254. The primary sequence number on your primary database, and here it is 186. So almost approximately 60 archive logs should be transferred from your primary to standby. So now let me again redo this enabling the parameter value, and I should be pretty quick to capture the port number from here and then check what is the detail from here. So let me be ready with that port number. Yes, I am ready with that, and as soon as I give enable here, I have to capture the port number which is using at that moment, and I have to at least capture the OS level process ID which is using my port number. So let me be quick there. Before that, let me enable this and then capture it. 9672 is the one, and 73 is the one, and 77 is the one. Okay, I got some process ID now, 77 who was doing it. So let us see which is the background process doing this. Now we have identified which background process was actually shipping the archive logs from primary to standby. And if you see properly, always the redo logs are being shipped from your primary to standby. This is always the one. That's also the third one that I have wanted to prove from this video, that archive logs are always being shipped from your primary to standby. That means the archiver process on the primary database side will actually push the redo log file, push the archive log files from your primary side to standby. This is the third proof that I can get from this exercise. So what is that we have proved in this video? First thing, whenever your primary database and your standby database are in sync, the redo transport is actually being done by your background process called NSA, and whenever there is an archive log gap from your primary database and your standby database, the gap resolution automatically is being done by your ARC process on your primary database server. Thanks for hearing to this video. See you again with interesting concepts like this again. If you have any queries, you can actually reach me on the various methods of communication you have on the screen. You can SMS me or WhatsApp me or give me a call on the number, or you can drop me an email also. I'll be happy to serve you whenever I'm free. Thank you once again. Have a good day. Bye-bye.